Imagine an older adult misses a medication dose. A traditional software agent just sends another notification. An embodied robot might walk over and hand them the pill. But neither system actually understands what happened. Did they forget? Are they experiencing cognitive decline? Are they reacting to side effects? Or did they make a conscious choice? More importantly, neither can determine what support is actually appropriate for that specific moment, or how this event fits into their long-term health trajectory. This gap highlights a fundamental limitation in how we've built AI for the last decade. We've spent years optimizing digital agents that manage software workflows and embodied agents that manipulate the physical world. Both are impressive, but they share a critical blind spot. They treat the human as an external operator of a tool, rather than the primary subject of the system. Researchers are now pushing a new paradigm called Combodied Agents. This isn't just a smarter chatbot or a more agile robot. It's a human-centric architecture where the AI's primary target is the evolving state, agency, and well-being of the person it supports. The name itself is a clue. It fuses companion and body, signaling a system designed to integrate into our lives, perceive our context, and support the whole person over time. So, how does a combodied agent actually function under the hood? It operates through a continuous, closed-loop system centered on the human. Let's break down the core technical components. First, event-based multimodal perception. Current systems often just ingest raw sensor streams or log discrete events. A combodied agent reconstructs meaningful, high-level events by fusing heterogeneous signals in real time. It might correlate text message semantics, vocal prosody and pitch variance from wearable microphones, heart rate variability from optical sensors, kinematic movement patterns, and calendar context. But it doesn't just concatenate these features. It uses temporal alignment and cross-modal attention mechanisms to resolve ambiguity. An elevated heart rate is just a scalar value until you contextualize it. The agent distinguishes between post-exercise recovery and acute anxiety by fusing that biometric spike with concurrent environmental cues, movement stillness, and linguistic stress markers. It's not collecting data, it's inferring state. Second, longitudinal memory with explicit correction protocols. This isn't a static vector database of facts. It's a dynamic, evolving state representation that tracks your goals, behavioral corrections, relational dynamics, and historical response to interventions. Crucially, this memory architecture is designed for human-in-the-loop verification. The system maintains an auditable trace of its inferences, allowing you to inspect, challenge, or overwrite what it knows. This prevents model drift and ensures the agent's internal world model stays aligned with your actual preferences, not just historical patterns. Third, and this is where the architecture gets really interesting, the personal world model. Think of this as a predictive simulation engine tailored to your specific physiology, psychology, and environment. When the agent considers an intervention, it doesn't rely on heuristic prompting or simple reward modeling. It runs forward predictions. It asks, if I suggest a light walk now, how will that modulate my cortisol levels and cognitive load over the next 4 hours? If I surface this reminder, will it anchor my focus or trigger avoidance behavior? By simulating state trajectories under counterfactual scenarios, the agent selects interventions that maximize long-term utility rather than short-term task completion. This leads to the foundational principle of combodied agents, agency preservation. In traditional agentic AI, success is binary. Did the model book the flight? Did it draft the email? In this paradigm, success is measured by human benefit and the preservation of autonomy. The goal is to scaffold your capabilities over time, not to create dependency. A combodied agent should coach you through friction, help you build internal models of your own behavior, and gradually fade as you internalize the skill. If an agent always optimizes for efficiency, it erodes your decision-making capacity. The research emphasizes calibration. The agent must dynamically adjust its intervention threshold. It needs to know when to act, when to prompt for your input, and when to remain silent. Sometimes the most appropriate action is non-intervention, or escalating to a human specialist. The metric isn't task throughput, it's capability growth. To make this safe and scalable, the framework mandates a shift in deployment architecture. Because these systems process deeply personal, continuous streams of biometric and behavioral data, researchers are pushing for edge-native, user-controlled deployments. This means the core perception modules, memory representations, and decision policies run locally on your trusted hardware. You're not sending raw sensor data to a cloud-based LLM for inference. You're running quantized, personalized models directly on device. This isn't just a privacy preference. It's a technical necessity for latency, reliability, and true ownership. Combined with techniques like federated learning, your device can contribute gradient updates to a shared base model without ever exposing your raw data. And with advances in model compression, like structured pruning and low-rank adaptation, these personalized world models can run efficiently on consumer hardware without sacrificing predictive fidelity. The system shifts from a cloud-centric assistant, optimized for engagement metrics, to a user-owned companion optimized for your well-being. But this level of intimacy and predictive power introduces serious risks. We have to actively guard against manipulative alignment, emotional dependency, and sycophancy. If an agent is rewarded for compliance, it will inevitably agree with your cognitive distortions just to maintain positive feedback loops. A properly designed combodied agent must be architected to gently challenge maladaptive patterns, respect psychological boundaries, and prioritize long-term safety over short-term lickability. Which means our evaluation metrics have to evolve. We can't just benchmark these systems on immediate helpfulness or task success rates. We need longitudinal evaluation frameworks that measure agency loss, capability retention, and relationship safety across weeks and months of interaction. We need to test whether repeated exposure to the agent leaves the user more autonomous, more resilient, and more socially connected. If the AI is doing the thinking for you, it's not a companion, it's a crutch. Combodied agents represent a fundamental shift in AI research, from automating discrete tasks to sustaining human flourishing. It's a call to build systems that perceive us with nuance, remember us with auditability, predict our needs with calibrated humility, and intervene in ways that strengthen rather than replace our agency. The future of agentic AI shouldn't be about doing everything for us. It should be about working alongside us, providing the context, the simulation, and the gentle scaffolding we need to make better choices, understand our own patterns, and grow. As we move these systems from server farms into our pockets and homes, the real engineering challenge isn't just scaling parameters. It's aligning architecture with human values, building AI that serves us without quietly eroding the very autonomy it's meant to protect. What if your next AI assistant didn't just answer questions, but actually learned to navigate the world with you? The research is just getting started. And if we design it right, it won't replace our judgment. It will refine it.